We have a video here. It's going to be on factoring a quadratic trinomial. And this is part one of a two-part series. This one here is part one. It's talking about if we have, part one is when the number in front of x squared is going to be a 1. The number in front of x squared is 1. And factoring a trinomial. Part two is when that number in front of x squared is not 1, when it's some other number. So let's look at what this means. If the question were to say graph y equals x squared minus 4x plus 3, this is what the graph would look like. If the question would say solve, find the roots, find the x-intercepts, or these three kind of go together. This next one it's called factoring. So if it said solve x squared minus 4x plus 3, or if it said find the roots of it, find the x-intercepts, or if it said factor x squared minus 4x plus 3. All right, first off, we'll show you how to factor it. When you factor it, what factoring means is a factor is you're trying to find the numbers that multiply to get this. And the two numbers that multiply to get x squared minus 4x plus 3, the two numbers would be x minus 3, x minus 1. And you say, you know what, that doesn't look like two numbers. Well, we know that what's in this first parentheses, that is one number. Just because there's a variable in there doesn't mean it's more than one number. That is one number. And then what's inside the second parentheses is the other factor of x squared minus 4x plus 3. So we have our two factors. X minus 3 is one of them, and our other factor is x minus 1. You could check this by using FOIL or multiplying the binomials. FOIL and multiplying the binomials is the same thing. So, I mean, you could go ahead and check this if you wanted, which you should get x squared minus 4x plus 3. Okay, so that's factoring. Well, what if it said solve? Find the roots, find the x-intercepts. Well, in that case, this is going to say equals 0. This will be equal to 0. And in order to solve this, you have to put each factor equal to 0. The second factor equal to 0. And from here, you just solve each one out. You have two problems. You add 3, so x is going to equal 3. The one on the right, you're going to add 1, so x is equal to positive 1. And so if we look at these numbers, x equals 3, compare that on the graph, and x equals 1. And you see that's where the graph crosses the x-axis. Those are also called the roots, and sometimes they're called the solution. So we need to, you can factor and find the answers, find the x-intercepts or find the roots without even graphing. So you don't have to graph to find the roots or to find the x-intercepts. That's where factoring comes into place. Sometimes factoring is a little bit quicker than graphing, but you still need to know both of them. Still need to know both ways. So this is what we do. This is how we factor. Let's look at this this example here. The one on the left says factor x squared plus 2x equals, or I'm sorry, x squared plus 2x minus 35. Well, the number in front of x squared is a 1, the invisible 1. So we need to multiply those two numbers together. Those two numbers multiplied together, let's make a little table here. So we have 1 times negative 35. You got to pay attention to your signs. So that's negative 35. And you see this one here? The number in front of x is a positive 2. So can you give me two numbers that multiply to get negative 35 that add up to get positive 2? Two numbers that multiply to get negative 35 that add up to get positive 2. And this is why it's helpful to know your math facts here. Numbers that multiply to get 35, well, that's going to be 1 and 35. But remember, it has to be negative 35. So it's both of those. Well, 1 plus negative 35 is negative 34. And negative 1 plus 35 is positive 34. And we know that these are not 2, so these will not work. And I'm just crossing these off to show you that they won't work. You don't have to cross those off on your paper. You can just know that they don't work because it doesn't equal positive 2. Other numbers that multiply to get negative 35, how about 7? 7 and 5. We know it's got to be negative 35, so one of them has to be a negative. Right here, 7 plus negative 5 is 2. And the next one down, negative 7 plus 5 is negative 2. So which one is the winner? It is not negative 7 and 5. So we have a winner here, and the winner is, you see how those match up? So let me get rid of my little arrow there. So the winner is positive 7 and negative 5. Positive 7 and negative 5. So we have to take those two. Take those two. And we're going to, oh, crash and burn there. All right, we're back online. We're back online. All right, we're going to take 7 and negative 5. And you see this positive 2x? What I want to do is I want to rewrite positive 2x to say negative 7x plus 5x. You notice how right here, positive 2, that's equal to positive 2x is equal to negative 7x plus 5. So I haven't changed the problem, I've just made it look a little different. Just made it look a little different. All right, so this is where we're at. And now I haven't done anything to x squared, it's still x squared, and I haven't done anything to negative 35, it's still negative 35. Okie dokie. So now, let's look here. I'm going to erase this little table that I have. We still have y equals out here to the side. So what I want you to do is I want you to underline those first two and underline the second two terms. So the first two terms, we have x squared minus 7x. What do you see in both x squared and 7x? Well, if we look, x squared is x times x minus 7 times x. You see ax, you see one x in both of those, right? So what you should be writing is you put that x outside, that x goes outside, and what is left inside? X minus 7 is left inside the parentheses. Now let's go back over to the left side to our problem and write that x times the difference of x and 7. And if you notice, x squared minus 7 is all of that right there that I've just written in yellow. That's x squared minus 7x. written in yellow. If you take and distribute, that's not a good distributive. If you take x times x is x squared, and x times negative 7 is negative 7x. So, once again, we've just changed the way the problem looks like. And now let's go from there, and let me erase my work again. Now let's take that the second set of numbers. Positive 5x, don't forget it's a positive 5x. 35. Well, what number goes into both of those? What number goes into both of those? Well, we have 5 times x, and we have minus 7 times 5. 7 times 5 is 35, and that's where we're getting 7 times 5 at. And if you notice, you see a 5, and you see a 5. That's in both of those. So that's what you're pulling out to right here, 5. And then what's left? X is left, negative 7 is left. This is what you have. How about this 5? Did we pull out a positive 5 or a negative 5? Well, we pulled out a positive 5. And so we have to take and rewrite this over here on the left side. Positive 5, and then x minus 7 in parentheses. So y is equal to that. So this is what we have. This is what we have. Okay. So now let's finish this. Let's finish factoring. You notice that you have x minus 7 in both parentheses, and that's your whole goal. You're trying to get x minus 7 in both parentheses, because when you can do that, you can take, just watch this part here. If I have x plus 5, and I have x minus 7 in parentheses, what you have to do is you have to take this x and multiply it by everything inside. So it's going to look like x times x minus 7. Then you have to take this positive 5 and multiply it by everything inside. So it looks like this. This is multiplying binomials. So now, what I've done is I've started with this, and we ended up with this. What you're doing up here is the opposite. You're starting with this, and you're supposed to end up with this. And let me explain that. Like I said, you have x minus 7, you have x minus 7, so that goes inside one parentheses. They go together. And then these two things, x and positive 5, they go inside their own parentheses, and they go inside it together. And you might ask, how can this happen? Well, look at what I've done down here. That works. It works out to be what we had right here. And so this is factoring by grouping. Some other people will show you how to factor a little differently, and it's going to be a lot quicker. I want you to learn how to factor by grouping first, and then if you know how to factor the quicker way, I will show you that in person. But I want you to learn how to factor by grouping first, because when we come to problems where there's a number in front of x squared, sometimes factor by grouping makes it a lot easier for you guys to solve. So I want to show you factor by grouping first, and then if you can, if you know you're capable of doing the quicker way, I'll show you that, and we'll go from there. But I need you to know how to do this first. Okay, that's factoring. So we have the two factors. The two factors are x minus 7 and x plus 5. So now, what if we come to a problem that says solve or find the x-intercepts, and I forgot finding roots, or find the roots of that problem. Well, if we notice that x squared plus 2x minus 35 is the same thing that we have here in our factoring problem. Okay? So when you go to solve this on the right side, what you have to do first is you have to factor x squared plus 2x minus 35. That's your first step, is to factor that. And when we factored it, we were able to get x minus 7, x plus 5. Now that's equal to 0. I showed you quickly on the last slide, x minus 7, x plus 5. You have to set each one equal to 0. Set each one equal to 0. So we add 7 to both sides, so x is equal to 7. We subtract 5 from both sides, so x is equal to negative 5. Now you might try and figure out why we do this. Well, go back here to this part. What number can you plug in here to make this a 0 times some other number, because it has to equal 0? Okay? Well, that number that you plug into there is going to be right here, 7. 7 minus 7 times 7 plus 5, is that equal to 0? Well, 7 minus 7 is 0. 7 plus 5 is 12. And 0 times 12, yes, it is equal to 0. So we have found one number so far. But remember, you have to do both sets of parentheses equal to 0. So what number can you plug in here to make 0? And it doesn't matter what this is, because this number times 0 is equal to 0. Well, I'm going to venture to say that you plug negative 5 in there. So if we plug negative 5 in for x, that equals 0. Negative 5 minus 7 is negative 12, and negative 5 plus 5 is 0. And that is equal to 0. And so that's the reason why we have two answers, is because there are two roots, because it is that quadratic graph that you saw on the previous slide. It crosses the x-axis twice, and it crosses at negative 5, positive 7. Positive 7 is somewhere like here. Negative 5 is somewhere probably here. And that's just a quick sketch. That's not precise, and that's not exact. I'm showing you that that's the roots. That's are the x-intercepts right there. Okie dokie. Let's look here. This one says factor. So let's go ahead and make our table. Make our table. So you got to take this number and multiply them. 1 times positive 9 gives you 9. And then this number here, positive 6, goes here. So what are two numbers that multiply? They have to multiply to get 9, but they have to add to get positive 6. Let me make that look like U. Kind of looks like a U there for multiply. Two numbers that multiply to get 9, that add up to get 6. Well, if it's a positive 9, 1 times 9 makes positive 9, but don't forget that negative 1 times negative 9 also makes a positive 9. We could use 3 and 3, or we could use negative 3, negative 3. All four sets of those numbers multiply to get positive 9. Now, let's add them up. 1 plus 9 is 10. Negative 1 plus negative 9 is negative 10. 3 plus 3 is 6. And it looks like that's our winner, because negative 3 and negative 3 make negative 6. So this one right here are the two numbers that we will be using. So now what you have to do is you just have to, once you get this process down, I mean, it's basically the same process. You just have to remember what to do. You just have to remember what to do. All right, so we take these numbers, 3 and 3. Positive 3x plus 3x. What is 3x plus 3x? Well, that should be 6x. So all we're doing is changing the way 6x looks, and we're changing it to say positive 3x plus 3x. And bring down everything else. Okay, underline the first two, underline the second two terms. So this is where we're at. Let's go with the first two terms. X squared plus 3x. Well, what goes into both of those? I'm doing this little extra work here. You don't have to put this down if you can recognize that there is an x in both of them. So this x comes outside. And what is left inside the parentheses? That x and that positive 3. So let's go ahead and take that and rewrite that over here. Y is equal to, and that's the first two terms. Now let's look at the second two terms. Second two terms, 3x plus 9. 3x plus 9. Well, 3x is 3 times x, and 9 is 3 times 3. I could have picked 1 times 9, but 1 times 9 doesn't allow me to circle those 3's and saying that I see a 3 in both of those. Okay? So what I do is I pull this 3. Let me draw a line here to separate those. I pull that 3 outside, and is that a positive 3 that we're pulling out? Okay? And what do we have left inside? Well, you have an x. That would be an x, not an f. You have an x left inside, and then you have, that's a positive, so then you have a positive 3 left inside. And the whole goal, remember, x plus 3, x plus 3. That's what we're trying to get. So let me take this and rewrite it. Over here on the left side, underneath 3x plus 9. So we say positive 3 and then x plus 3. So this is what we have. And from here, we're trying to make two sets of parentheses. So this goes in one of them. X plus 3 goes in one of them. And then this goes into the other one. X plus 3. So this is what we have. Y is equal to x plus 3 times x plus 3. And you should recognize that y is equal to x plus 3 multiplied by itself, which is x plus 3 raised to the second power. So that's that part of the problem. We have it factored out. Now, the second part of the problem, if you come up with something like this that says solve or find the x-intercepts, and once again, I need to say roots, find the roots. You come across the problem that says that. Let's notice how x squared plus 6x plus 9 is the same as what we had when we were factoring. So basically, your first step is to factor this. And when you factor it, you get x plus 3, x plus 3 equals 0. And so what you're trying to do is you're trying to find the values that you can plug in for x to make all this equal to 0. So remember, you have two problems now. Set each one of them equal to 0. And you should notice that they're both the same problem. X is equal to -3, and X is also equal to -3. So your answer for solving, X equals -3. You don't need to say X equals -3 and -3 because it is the same. It's the same. This type of graph, 1, 2, 3, will look something like this. Okay, when you graph it, the vertex sits right on the x-axis. So that makes you only have one root or one x-intercept. All right, this one says find the x-intercepts. We're only going to do one problem here. In the previous two examples, I kind of split it up into two problems, but we're just going to go ahead and do one problem. If it says find the x-intercepts, you know the x-intercept that y should equal 0. So y is equal to 0. So let's go ahead and do this. Make our little chart here. Has to multiply to get, what's 1 times 36? That should be positive 36. Multiply to get positive 36. Add up to get -12. Multiply to get positive 36. Add up to get -12. Well, let's go ahead and do this. Let's say 1 and 36. 2 and 18. 3 and 12. 4, 9, 6 and 6. And then the next one we come to is 6 and 6. And then we're going to go back up to, like, say, 9 and 4, which we're getting back to pairs that we've already had. Now, if you're questioning on how to find this, you just need to know numbers that multiply to get 36. Now, remember, let's go ahead and add all these up. This should be 37. You get 20. You get 15. You're going to get 13. You're going to get 12. But none of those are -12. We're trying to get -12. Remember, to get a positive, you could also say, this looks like -12, right? What if we put -6 and -6? Does that multiply to get positive 36? It sure does. And then it also adds up to get -12. So we're going to use -6 and -6 here. So -12 breaks down into -6x minus 6x. Bring down positive 36 and bring down your x squared. You're finding the x-intercepts, so therefore y should equal 0. The next step is to underline the first terms, underline the second two terms. All right, first two terms. X squared minus 6x. Okay, what do you see in both of them? I see an x and I see an x. So that's the x that comes outside the parentheses. And what is left inside? X, -6. So that is what we write below there. And let's go ahead and take this second, -6x and positive 36. Well, we know that this is negative. We know that it is like -1 times 6 times x. And look here, 6, right? Well, I know 6 goes into 36. That's 6 times 6. So that's the factors of 36 that I'm looking to make. Because when I make those factors of 36, then I get the 6 that I can pull outside. So I pull that outside. And what is left to go inside? Well, you have -1 times x, which is -x. and then you also have positive 6. You got a problem, and this is a problem you need to pay attention to. Those are not the same. Inside, it's not the same. Huh. Well, I do notice that we do have an x and we do have a 6, just like we have an x and 6 over here. It's just the signs are different, right? It's just the signs are different. That's no big deal. All that means is, let me go back to this step. Let me go back to this step, and I'm going to rewrite what I just had there. Negative 1 times 6 times x, and this is 6 times 6. Okay, so since all we needed to do was get different signs, of this one that we're working on right now, we needed the signs to be different. The x needed to be positive, and the 6 inside the parentheses needed to be negative. So what you can do is you can pull out that negative 1. And you can pull it out with this number right here. You can think of it as negative 6. And what two numbers multiply to get a positive 36? Negative 6 times negative 6 gives you the positive 36. And so in doing that, now we see a negative 6 in both of them. So we have negative 6 here, and then what do we put inside? X minus 6. Now we notice that what's inside the parentheses is the same. What's inside the parentheses is the same. Okay, so now let's go ahead and take all this and rewrite it over here. Negative 6 and x minus 6. And bring down equals 0. Okie dokie. These two go inside of one parentheses. And these two go inside the other parentheses. And we know that this needs to have two parts to the problem. So the first one comes there. And the second one, you set it equal to 0. And solve these out. And in solving these out, you know that you're going to get the same number for both of them, which is positive 6. So you'll get positive 6 for both of them. And that's the answer. You have found the x-intercepts of that quadratic function. We'll take a brief break here, and then the next video will be up next.